few more notes on 6.3 here, graphing radical or graphing root functions. We kind of only got through the square root functions yesterday, or talked a little bit about even roots. So I want to do an odd root for you and just give you a general idea what those are going to look like. Let's say we need to just graph the simple cube root function, y equals the cube root of x, okay? Y equals the cube root of x. I would guess that most of you could probably make a table of values mentally, but if you don't want to, or not really good at that, okay, you definitely could type this into your graphing calculator, okay, to help you make a table of values or to help you graph this, okay. When you type this in your graphing calculator, y equals the cube root of x. There's two ways to do a cube root. You can actually do cube root, so y equals the cube root of x. The cube root function is underneath your math button. If you hit math, it's kind of in the top left corner of your graphing calculator. If you hit math, you can see one of the choices there is cube root. I don't know which one down is it. Fourth one down. The fourth one down is the cube root, so you go y equals math, cube root, and then x. Press enter, and you could graph it that way. Or you could also just type in y equals x raised to the what power? 1/3. Yep. Either way is fine. Both work. Okay. So if you want to use your graphing calculators, you certainly can to come up with a table of values for this. Okay. If you this one you can probably do mentally. It's a cube root. Okay. Pick some nice numbers that are perfect cubes. Okay. So if you plug in a 0 for x, what is the cube root of 0? 0. So 0 comma 0 was a point that I plotted. Okay. What's another nice number?
8.
8. What's the cube root of 8?
2.
2. So I went to 8 comma 2, plotted that point. What's more?
64.
64. 4. Yep, 64, 4. Ran out of space. I didn't put that one on there.
Yeah.
But yeah, obviously here's an easy one. 1, 1, right? The cube root of 1 is 1 because 1 times 1 times 1 is 1. Okay. Some negatives. -1, -1, -8, -2. So what are you noticing is different with this cube root versus a square root?
Cube roots.
They go forever both directions, right? The cube roots. Okay. Why would the cube roots be able to go both directions?
Because you can have an odd root of a negative number.
Nice job. You can do odd roots of negative numbers. What can you not do?
Even roots.
Even roots of negative numbers. Okay? So that's the reason why this one goes forever in both directions, because it's an odd root. Odd roots are always going to look something like this. Okay? So we plotted the points, drew the graph. You could look at the graph on your graphing calculator to help you draw it. Look at your table to draw it. Domain and range. Does that make sense with our picture? Can you plug in any number in the world for x and expect to get an answer? Yep. Because you can do the cube root, you can do an odd root of any number. Okay? So every x value is touched. Every x value from negative infinity to positive infinity. Every x value is hit. So that's why my domain is negative infinity to positive infinity. Y values also are negative infinity to positive infinity, because does this graph go down to negative infinity forever? Yeah, it's slowly going down, but it's going down. All right? Does it go up to positive infinity forever? Yep, it does, slowly. Okay, even out at 64, it's only up to 4. All right, but it'll keep going. Okay, because numbers keep going. So domain and range. Domain and range of odd roots will always be this. Okay? But that's different than even roots. Why is it, again, different than even roots? You can't do even roots of negative numbers. Okay? Have I said that a couple times? Okay? I'm hoping it's getting redundant. The reason I've said it a couple times, you'll have to write that at some point on a test as to why The domains are different. You can't do even roots of negative numbers. That's why the graphs of even roots don't go both ways, left and right, forever. Because you can't do even roots of negative numbers. Okay? If you have bad memory, maybe write that big bold cap somewhere in your notes. You can't do even roots of negative numbers. But you can do odd roots of negative numbers. Okay? So there's a cube root graph. Okay on that? Again, if you can't find the cube root button, or I know there's not a fifth root button, there's an xth root, so you can use a 5 then, all right? But if you don't want to use a fifth root, you can instead raise it to the 1/5 power. Everybody remember that? Okay? All right. I want to do one more complicated graph. How am I sitting? About 5 minutes? 6 minutes? Okay, I think I got time. Okay. I want to do one kind of complicated graph here. This was what I gave you originally, right here. Okay. Graph and state the domain and range, and the equation I'm giving you is y equals 2 times the quantity x plus 1 raised to the 1/2 power minus 3. So y equals 2 times the quantity x plus 1 raised to the 1/2 power minus 3. Now some of you might be thinking, originally, obviously you can see my work up there, okay, but originally you might be thinking, well, where's the radical symbol? Where's the root symbol, right? Okay, there isn't a radical symbol up there. But what power do you see? 1/2 power. A 1/2 power is really what? A square root, okay? So if you would prefer to rewrite it with a square root, because you like the looks of that better, do it. If you don't, keep it as it is. I don't care. Whatever makes most sense to you. They're the same thing. All right, 1/2 power, square root. 49 to the 1/2 power is 7. Square root of 49 is 7. Okay, they're the same thing. Okay? So either one of these is what I would probably type into my graphing calculator to get my table of values. Unless you just like plugging in numbers for x and seeing what you get for y mentally, which you're more than welcome to. Okay? But I would definitely probably type one of these into my graphing calculator and let the graphing calculator get the table of values for me. Okay? I would strongly recommend, I know you can see all the values up here, but I would practice typing that into your calculator here right now. Okay? Make sure you know how to enter all those things into your graphing calculator. Now versus later. See if you can type in either of those. I don't care which one you use. You want to use square root, go for it. You want to use the 1/2 power, go for it. But type those into, type that function into your graphing calculator and make sure you can see the table of values that goes with this function. If you're having trouble, say something. So type it into your graphing calculator. If you hit the graph button, obviously you'll see this graph. Probably not super useful. I'd go to your table of values, which is second graph, okay? I'd go to your table of values and try to pick out the points that are nice, okay? And by nice, I mean integers, whole numbers, okay? So, we doing okay? So go to your table of values, plot those points on your graph, draw your graph, and it looks like this, which... Is that what you would have guessed it probably looked like? What does a square root graph look like?
Half a parabola.
Half of a sideways parabola, right? Okay? A square root always kind of looks like this. It only goes one direction.
What's your thing?
Okay? Odd roots go both directions, right? Okay, but this is a square root, so it's just going to go as half of a sideways parabola. So I drew the graph. Domain. Domain is all of your what values? X values. So as we go left to right, what X values is this graph touching? Every number from where to where?
Yeah.
From -1 to infinity, all right? It's not touching any x values, not touching any x values. Oh, here it hits an x value at -1, and then the graph keeps going to the right. So my domain then is every number from -1 to positive infinity. So I write it this way. Why do I put a square bracket on the -1?
Because it
Actually touches -1. Okay, that's kind of where it starts, right? Okay. Range. Range is your y values. So you think bottom to top. What y values is this graph touching? Every number from -3 on up, right? So we write -3 to positive infinity for the range.
So when we have ones that don't touch an x value, do we still bracket on
If there were an open circle right here instead of a closed, which doesn't happen in square root functions, but in other functions, okay, that you will have someday, okay? If this were an open circle here and not a closed circle, then this would be a parentheses, and that would be a parentheses, because it gets really close to that value but never actually touches it. Does that make sense?
Yeah.
Okay. Any other questions?